Now we are going to have a look at the mobile app based harmonic distortion analyzer for power quality assessment. First, we'll have an overview about the harmonic distortion analyzer's hardware setup. It all starts with a 230 volt AC power line supply. This is an auto transformer used for controlling the voltage supply. Here is the triac, which is used for controlling the firing angle of the AC line. Now for the load, we have used a lamp load here. This is the current THD analyzer's hardware setup. This is the voltage THD analyzer's hardware setup. Here comes the MCU and the Bluetooth communication unit. Let's have a look at the voltage THD analysis that is done using the hardware setup and observe the waveforms on the mobile app. Now we are going to begin the analysis. First we ensure that the triac is set to minimum, that is the firing angle is set to 0. Now we are going to switch on the lamp load. So this is the app that we are using to analyze the total harmonic distortion which we have developed. So first we are going to connect it. So this is the Bluetooth device that has been listed here. So now update button is pressed. So you can see a status here called connected. Each and every time you click on update, the value gets updated. Here is a spectrum graph for different order of harmonics. All the odd harmonic values are displayed here because that is the dominating one when compared to the even harmonics. And back, now we are going to have a look at the waveform. Again the procedure is same. To connect it to the Bluetooth dongle first, and after that click on update. So you can see that the waveform is getting plotted. So this is, since track is set to minimum, you can see a pure sine wave. Disconnect back, again we'll measure voltage THD, connect it to the dongle. Now we are going to vary the firing angle. You can see the brightness of the lamp going down. And again update. So it is clear that the THD value is increased. So the scale is not fixed, it varies according to the maximum value of the THD. Again, you can see the brightness going down because of the firing angle. We vary the firing angle now. So again, I'm going to press on update. So the THD value gets increased to 124. So again, the bar gas, the spectrum graph gets updated. So again, I'm going to try with a new firing angle. Again, spectrum graph. Since we have varied the firing angle a couple of times, it will be better like if we have a look at the waveform so that we get a clear view. So now we are going to have a look at the waveform window, disconnecting it, but going back. Before entering into the plot waveform window, it will be better like if you go into the measure voltage THD, and so that we'll get a clear view of the waveform that we are going to observe for this THD value. The THD value is 170. Going back, entering into the plot waveform window, connecting it to the dongle, and then update. So we'll get the waveform now. Yeah, update. So here's the waveform. So this is how the waveform is for the corresponding THD value. Similarly, we are going to have a look into the current THD analysis and its waveform plot in the mobile application. Again, with zero firing angle, we are going to switch on the lamp load. Now, getting into the measure current THD tab. Again, the procedures are same that we followed for measuring the voltage THD. The only difference here is that it will update the current THD values. So you can see the current THD value here, total THD is displayed. So the graph gets accordingly updated to the values that is being recorded above. So these are the values. So I'm disconnecting it from this, going back, and we're going to have a look into the plot of the waveform. So now update. You can see the minute glitches here, that is because of the triac circuit. Again disconnect, going back. Now we'll do the same experiment of varying the bulb's intensity and measuring the effect of harmonics with respect to current. Again going into the measured current THD tab, connecting it with the dongle, and then update. Yeah, you can see the THD value is being updated to 51.85 percentage. Again the spectrum graph is also being updated. Now again varying the firing angle, updating the values, you get the values to be yeah, that is now updated. You can see the spectrum graph here. Again repeating the same procedure for a different firing angle. So you can see the value being updated here to be as 81. Now that we have seen the output from the experimental instrument, we have to verify it with the Fluke 434 energy analyzer. This is the output window of the Fluke 434 energy analyzer, and this is the serial monitor output of the experimental instrument. So you can see that the THD value is 38.77 percentage, and in the Fluke it says that the total THD is 40.8 percentage. Now we'll be comparing each and every individual harmonic, that is from H1, H2, H3, etc. till H15. So we'll be comparing the results from this Fluke with the experimental setup. So H10, H11, H12, H13. After 15 the display is made off, so you cannot see after 15 in this Fluke. But with respect to this experimental output window, so we'll be able to see till the 25th order. So each and every individual THD values can be observed clearly here. A comparison chart is also made here, H24, H25, and the total THD. Now we have to observe the waveform simultaneously on both Fluke image analyzer and the experimental instruments serial window. This is actually a serial plotter window, which is of the experimental output. So they both of them are kept parallelly, and you could see clearly the waveform variations. The track is being continuously varied here, so now it is clear that both the windows of serial monitor and the Fluke gets matched here. Now it is a proper sine wave. So again in the serial window also it has been changed to proper sine wave. In order to have a clear view, we will be going closer into the serial plotter of the experimental setup. So now this is the Fluke image analyzer. You can see the waveform again, and this is the waveform from the serial plotter. So both of them matches together.